All right. So I want to do one more demo showing the how helpful these command line tools like Codex are. Again, like this is super raw. I haven't done this before. I haven't done this, prepared for this. I just have some data and an idea, and I want to explore. So basically, the powerful thing that I recently tried that I really liked is you can use AI to generate certain hypotheses. You have, let's say, some data. Okay, let me first describe the data, right? So there's this political emails data, right? Like, so there's a lot of these emails that political parties send are now public, right? Like, so let's say, okay, a lot of these are UK, but let's say Conservative Party, whatever it is. Okay. Um, okay, let's say Green Party, right? Like, so these are Green Party, or Green Party is not a thing in the US, but what is this? Okay, by country. Yeah, okay. I mean, so that's a big database, right? Like, so that's a million plus messages. And like all of these are super PACs, there are things like that, ACLU, all of that stuff. But you can say rifle, let's say. Okay, there's a rifle association. Okay, apparently there. But anyway, so these are all candidates and their messages. Let's say let's check out Chuck Schumer or something. Uh, Chuck Grassley, right? This is the guy I know. Okay, he has sent like a lot of messages. Great day for what, like, and there's a lot of these, right? Like, so there's lots of emails that these candidates send, signing up for biofuels, uh, judiciary committee, and so on. So these are usually either updates that they send or campaign finance stuff and things like that. So we have that emails data set. So let me show you. So let's say, okay, so this was the other email, yeah, right? So we have that emails data set downloaded and standardized in some a big file. So this is the name of the person. So Ted Cruz, making America the greatest. So I think this is like some super PAC or something. And this is the subject is Biden impeachment, and date, year, month, minute, domain, body. So the body of the message is all, okay, should be removed, thrown in jail. So that's what Ted Cruz sent. Right, so you have a lot of emails like this. So this is a huge file. This is almost 500 megabytes and probably a million emails. Oh, no, actually, it's much smaller, 186,000 emails. So, okay, this is a big file. Now, I have another data set, which is this data set, which is a database on ideology, money in politics, and elections. It's called Time. It's from Stanford. This is like a very interesting data set. It really standardizes election campaign finance, like who received money from whom, and things like that, right? So I have these two files, right? There's a data set and the emails data set and the campaign finance data set. Okay, so I have some ideas now on like who is giving money to whom and the types of emails that they send, like are they influenced by each other or not. But the main thing that I want to use Codex for is actually doing this iterative process. So what I want to do is first ask Codex, okay, so describe it to it, the data sets that I have, what I just told you, and then ask it to come up with a plan of different hypotheses it wants to test, and then write it to a file and then read through that file and go through it. So I've done this previously, but what I did is I actually described it on ChatGPT, the interface, and then took ideas that I think would be interesting because a lot of them are like really junk, and that's what will happen here as well. But the key thing is even if it's able to generate like 20 hypotheses and one of those is good, and it happened to me in I mean I did this for another paper. It generated like 20 of those hypotheses, and like out of them, one of them or maybe three of them were really good, like really, really not what I had thought. Like it was, okay, there's this psychology dictionary, take that and combine it with this and do this. So it was really good. Like, and I just had to download that dictionary file and I just gave it to it and it said, okay, just work with it, and it took care of it. So that is the type of thing that I want here, right? Like, to look at these files, understand the data set, come up with these hypotheses, and then like implement each of those and give me the results. So let's see how that will work. I don't know if this is going to work, but let me try. So the first thing I want to do is, okay, I'm in that folder. I open Codex, and then I will first now just describe all the data sets that I have in detail. So let me just write down the description. I just pause the video. Okay, I mean, maybe I shouldn't pause the video and I just show you how I'm doing this, writing the prompt. So basically what I just said is, I just said, okay, I have these two files. The first file is emails.raw.csv, and here's how the file looks like. I pasted a couple of rows. Then I said, okay, another file is called dime. It is, so its name is like this. And then I copy pasted this thing from here, right? Let me just pass it. Um, the data set looks uh, like this. Okay. From There is a README file, which is I don't know, let me call it codebook file. There is a codebook file .pdf which contains details of the data set. Let me show you the code book actually. I can go here. Yeah, this is the code book, right? So basically, I want to tell it that, yeah, this one on page 7. Um, yeah, this is the candidate. Uh, there is information about on page 7 of this file. Please take a look to understand what the different columns mean. Okay, maybe I'll just also paste this. Okay, okay. So now let me just say, put another of this and say, okay, now your task is to first look at samples of the data set to clearly understand what they are. Dataset, and read the code book to clearly understand what they are. Second, to just filter out data from years 2020, 2019 to 2022 in both files. I'm assuming both files have, uh, and create clean copies. Join them by, so let's check actually. So I'm assuming this Witten Jamie Lloyd is like the name of the candidate. Uh, I'm assuming Senator Ted Cruz uh, is the name here. I don't know if it's gonna do this. It's a bit harder. But basically, what I want to say is, there'll be Ted Cruz in the dime file and Ted Cruz here, and it has to do that sort of join. So I want to say join them by name of the candidate. Uh, this join might need to be fuzzy and intelligent, because the names could slightly be different. Example, Senator Ted Cruz in one file, in the email file, and Ted Cruz in the dime file. Okay, so basically it has to do first this sort of joining, then propose. Let's say I usually do this. I don't think we need to do this these days, but I just say think deeply and come up with 10 different hypotheses of data intelligent data analytics, the analysis and research that I could do with this new joined data set. Write the hypotheses into a file titled hypothesis.txt, one per line. Please keep it very detailed and because these hypotheses will be prompts for a next round where we will take each of them and implement them. Okay, so this is my prompt. So what I'll do now, I don't know if this is going to work, but I'll just copy this and copy this, paste it here. Okay. Yeah, okay. So let's yeah, let's check how that works. I mean, this might take some time. So already, the prompt was super big, but it's fine. I think it's 1% of the context. And because this has like 128,000 context window. So, and now this Gemini also has a similar product. I haven't tried that, but I think that has like a million context windows. So that's much bigger, much easier, much better. Okay, so it's doing it, like it's checking these things out. Um, okay, so yeah, so this I'd say yes, always switch approval mode. So this is auto edit. Okay, so that will actually I will probably give like a full edit thing. So it's yeah, looking at section 5. So let me just check switch approval mode to full auto, and then I think it'll just do the thing, right? Like so, as you saw, like it looks at section 5.1. I don't know if I remember, I gave 5.1, but yeah, it's checking like these different things. Yeah, it's using some of those. Okay. Uh, okay. I mean, I think this will take some time, like probably a few minutes. Let me just pause the video here and we'll get back when I'll show you what it did maybe, but hopefully yeah, this is going to be a good success. Let me see. All right, I mean it was quite quick actually. It took like over a minute and a half or something. So but let me check. Okay, so if I do this, okay, so there's already, I mean, it didn't run the thing like it did last time, but so it'll say, okay, this is a thing that'll join the two files. So opens this, and then okay, there's some okay, and then for fuzzy matching, let's check actually like if this does the trick. I don't know if even the email data set is spans like 2019 or not, but I think so. But anyway, let's check what this will get us. And but already like this hypotheses file is super interesting, right? Like so it says, I mean, okay, these are simple, but still like analyze correlation between the volume of campaign emails sent by each candidate and their total fundraising receipts to assess whether higher outreach translates to greater financial support. Examine ideological orientation of candidates measured by these nominate scores relates to sentiment and partisan language, right? Okay, that's quite good. Like if the extremes send, certain types of emails and how much money they get. So I can develop this further, right? Like, so it gave me an idea. Now I can think and say, okay, yeah, look at extremes, look at the sentiment, and then look at, I mean, right now it's only looking at these one variable from the dime dataset, which is the partisanship, but I can also take the um, amounts that they got and their partisanship score and their sentiment and do this sort of thing. Investigate whether incumbents versus challengers differ. Frequency, okay, I don't know how I'll get that. Time of day, day of week effects, so on, right? Like, so this is already super duper interesting. Okay, so this apparently gave me an error. Okay, so this is in okay, there's some I think there's a like the data set is probably not properly formed. So I'll just paste this here. And the good thing about this is it'll rewrite these, right? Like, so it'll just look at that file and then automatically rewrite that instead of me pasting it to ChatGPT, copying that, pasting it here. So it just did the diff automatically. So, okay, it's already trying to run it, but this Python 3 it does not have pandas because of fucking Python versions. But anyway, if it is able to apply the patch and just give me the file, then I can just run it myself. Um, okay, so it said, okay, drop the empty name. So that's the problem, I think. Um, Okay, let's go back and look at the ideas that it gave. I mean, some of these are already super interesting. Investigate gender differences. Let me just check this, right? Like, so how it'll do this. So I can just, let's see if this works and it gives me the data. Then I can just directly say, okay, let's implement this idea. And we'll see, what that gives us. Okay, this is going to take some time, maybe, because I mean, each of these files are quite big, like, so it's half a gigabyte, so it has to do some sort of join. And okay, let me just pause the video here. Hopefully, this will run without it. Okay, I mean, yeah, it took like a couple of minutes, but I think it should be done. I don't think it'll work in the first try, but let's check. So it did do some joining, and okay, let's first check how many lines this has. If Okay, I mean, yeah, it's still not so bad actually. Like, if there's like half of the candidates we were able to find. So this is yeah, so this is Andy Bashir. Andy came. Okay, Andy came. Okay, because people send multiple emails. Okay, so there's some data, right? Like, I don't know. I mean, if I was doing this as a research project, like I'd be much, much more careful. This is just a demo. So now I'll say, okay, I want to implement this idea. Please give me a detailed plan on how you'll do it. Right? Like, so this is not that easy. I don't know if this thing has gender. Okay, maybe it has a gender. No, it doesn't have gender, I think. Right? Like, so it has to identify gender using some sort of name. So there should be using some dictionary. So it has to find that dictionary or tell me like where to get that dictionary from. So okay, so it did give me a really detailed plan, right? Like, so it says, okay, whatever, okay. Email sent, okay, feature extraction, merge features. Yeah, okay. How are you getting gender? Okay, well, I don't know. I mean, let's check it out. Okay, please implement it. Um, yeah, okay, so the data prep, blah, 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 blah. I mean, it did implement all of that. Like, I don't know where it got the gender information from. Let's check. Uh, there's the gender information. I don't know. There's a number of emails. Sample feature sentiment. What? Uh, yeah, I think this is messed up. Definitely. Right. So let's check actually. Um, this one gender. Okay, so it's trying to plot gender. Oh, okay, there is a candidate dot gender, right? Candidate dot gender. So why didn't this verify? Yeah, okay, yeah. Okay, so it did give me this. So let me just try to run this and let's see what it'll do. Um, okay, so it install. Okay. Again, like if I was doing this, I'd be much more careful. Obviously, I'll not ask you to generate the ideas and all that. But what I wanted to show here is, I think I got some pushback claiming that the AI, scientific process, academia is academic research is getting automated. I mean, and I really would have done this process myself, right? Like, so, okay, gotten this data, think of how you do the joining, then think of these ideas. I mean, some of those are obvious ideas, many of those are obvious ideas, but like, and so now I can just have like 20 minutes and I can even just tell it, okay, give me 10 scripts each for each of these, right? Again, I just say write it to a shell script. I just press run for that shell script. We'll just execute all the 10 scripts. If there's errors, okay, it'll skip or whatever. And then I can ask you to fix it. But now, okay, it's able to run that and generate some sort of plots for me that I can easily just check and verify. Okay, is the gender related to this sort of variable? So this would have taken like half a day for me, right? Or something else, or even more. Um, so this kind of process of doing this is extremely helpful. Like, so this is something that we should definitely teach our students, but also do ourselves. Like, yeah. Let's see. Firstly, if this is gonna work, I mean, it's running for some time, so let's see what we get out of this. I'll just pause. Okay, apparently, I mean, it did give me an error. Like, it did run some tests and give me some output, but it gave me an error. So I'll just paste that thing here. And I think it'll just fix that. So let me just, yeah, just show you the final result once I get it. And yeah, I'll talk then. All right. So, okay, it did run and it gave me the outcome. So, yeah, okay. So now I have to interpret this. So, okay, I mean, I think this is quite good. So it did do some. Okay, let me not be the worst or the worst person and just let it run. Like, what I want to check what it did. So, okay, firstly. Yeah, so the thing it did is, okay, campaign, general difference in campaign email outreach. Da, 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 da. Um, okay, it did some sort of regression of number of thing that was received based on gender, party, and controlling some of these. So okay, so gender male, negative coefficient. Okay, so mhm. Okay, yeah, I mean, this is somewhat okay, right? Like, I mean, these results are not super interesting, but you can already see that, okay, this is, it would have taken a long, long time. And now you can, ask it to implement some of these other ideas and, all of that stuff. Like, so, yeah, so so this is the power of Codex, and like this helps in this sort of massive iterative analysis and looking at results and back and forth things like that.